How to debug invalid reads in C++ with Valgrind. Have you ever faced the frustration of invalid reads in your C++ programs? If so, you are not alone. Today, we will tackle how to effectively debug these issues using Valgrind. Let's get started. First, you will want to run your program under Valgrind with the Memcheck tool activated. This tool is designed to detect when your program attempts to read memory it should not access. This includes reading beyond allocated blocks or accessing memory that has been freed or is uninitialized. To begin, execute your compiled C++ program with the command Valgrind leakcheck is equal to full. The option leakcheck is equal to full will also report memory leaks, but our main focus here is on invalid reads. Once you run the program, Valgrind will generate output that includes errors labeled as invalid read. It will provide details such as the size of the read, which could be 1 byte for a character or 4 bytes for an integer. You will also see a stack trace that shows where the invalid read occurred, along with the memory address involved. This information is key to identifying the exact line and function causing the problem. Next, it is important to understand what causes these invalid reads. They often happen when your program reads past the end of an allocated buffer, dereferences a null pointer, or uses memory that has already been freed. For example, if you pass a string to a function like printf that expects a null-terminated C string but the string is not properly terminated, Valgrind will flag this as an invalid read. Now, let's talk about fixing the code. Use the stack trace and error message from Valgrind to locate the problematic code. Common fixes include ensuring that buffers are properly sized and null-terminated, checking pointer validity before dereferencing, and correcting off-by-one errors in loops or array indexing. For instance, adding a null terminator to a character array can resolve invalid reads related to string handling. After making your changes, it is time to rerun Valgrind. This will help you confirm that the invalid read errors no longer appear. This iterative process is essential for ensuring that your memory access issues are resolved. If you still encounter complex bugs, consider combining Valgrind with a debugger like the new debugger. Valgrind can point out where the error is occurring, while the new debugger can help you inspect variables and the program state at runtime. This combination can make it easier to understand why the invalid read is happening. By following these steps, you can systematically identify and correct invalid reads in your C++ programs. Valgrind's detailed reports and stack traces are essential tools for mastering software debugging and fixing programming bugs related to memory access. So, get started with Valgrind today and improve the stability and correctness of your C++ applications.